Hello everyone and welcome to this video on data types in Python. Data types are one of the most fundamental concepts in programming, and in this video we'll explore how Python handles different types of data from numbers and text to collections and mappings. Whether you're new to Python or looking to strengthen your basics, this video will help you understand the role of data types in writing efficient and organized code. So let's get started and dive into the world of Python data types. Introduction. In Python, data types define the kind of value that a variable can hold. They play a crucial role in programming by specifying how the stored data will be interpreted, manipulated, or processed. For instance, a variable holding the numeric value can be used in mathematical operations, while a variable holding text is processed as a sequence of characters. Understanding data types is fundamental to writing efficient and error-free programs. Python offers a rich and diverse set of data types to handle different kinds of data, making it versatile and powerful for a wide range of applications. From numbers and strings to more complex structures like lists, dictionaries, and sets, Python's data types enable you to manage simple as well as advanced data structures with ease. Additionally, Python's dynamic nature allows you to assign values of different data types to variables without explicitly declaring their type, making it beginner friendly and flexible. By mastering Python's data types, you can write programs that are not only functional but also optimized for performance and readability. This foundational concept sets the stage for more advanced programming techniques and ensures that you can handle and manipulate data effectively in your projects. Basic data types in Python. Python provides a variety of basic data types to handle different kinds of data, making it a versatile language for diverse applications. These data types are the foundation of Python programming and allow you to store and manipulate numbers, text, and logical values. The first category is numeric types, which include int, float, and complex. An int represents integer numbers without a fractional part, such as 10. A float represents floating point numbers with decimals like 3.14. Lastly, the complex type is used for complex numbers which have a real part and an imaginary part, such as 2, 3j. These numeric types enable Python to handle a wide range of mathematical operations from simple arithmetic to advanced computations. Next, Python has the text type represented by str for strings. A string is a sequence of characters enclosed in single, double, or triple quotes. For instance, name Python defines a string variable name, and you can use the type function to confirm its type as class trish. Strings are incredibly versatile, allowing you to store and manipulate textual data effortlessly. Finally, Python includes the Boolean type represented by bool, which holds logical values true or false. These values are often used in decision making and conditional statements. For example, is underscore active true assigns the value true to the variable is underscore active, and type is underscore active confirms its type as class bool. Yeah. Understanding these basic data types is essential for working with data in Python. They allow you to represent and operate on different kinds of information effectively, setting the stage for more advanced programming concepts and real world applications. Sequence types. Python provides several sequence types that allow you to store and manage collections of data in an organized manner. These sequence types list, tuple, and range are versatile and cater to different use cases based on whether the data needs to be mutable or immutable or immutable. The list is one of the most commonly used sequence types in Python. It is an ordered collection of items, meaning the items retain the order in which they were added. Lists are also mutable, allowing you to add, remove, or modify elements after the list is created. For instance, my underscore list 1, 2, 3 Python is a list containing integers and a string. You can easily update the list by appending items or changing existing elements, making it ideal for dynamic data handling. The tuple, similar to a list, is an ordered collection of items, but it is immutable. Once a tuple is created, its elements cannot be changed. For example, my underscore tuple 1, 2, 3 Python defines a tuple with integers and a string. Tuples are often used when you want to ensure that the data remains constant throughout the program. They are also slightly faster than lists, making them suitable for scenarios where immutability is required. The range type is used to generate a sequence of numbers. It is often utilized in loops or when working with numeric sequences. For instance, my underscore range 5 creates a range object representing the numbers from 0 to 4. You can convert it to a list using list my underscore range to see the sequence explicitly as 0, 1, 2, 3, 4. The range is efficient and memory friendly as it doesn't store all numbers in memory but generates them on demand. Understanding these sequence types is crucial for working with collections of data in Python. Each type serves a unique purpose, allowing you to choose the best one based on whether you need mutability, immutability, or numeric sequences in your program. Mapping and set types. Python provides powerful data structures like dictionaries, sets, and frozen sets to handle collections of data effectively. These types allow you to manage data in unique ways, catering to different programming needs. The dictionary is a versatile mapping type in Python that stores data as key value pairs. Unlike sequences, dictionaries are unordered, meaning their elements don't have a specific position. Each key in a dictionary is unique and acts as an identifier for its corresponding value. For example, my underscore dict name Python version 3.9 creates a dictionary where name is a key with the value Python and version is a key with the value 3.9. Dictionaries are particularly useful when you need to associate related pieces of information, like a database of usernames and their passwords. The set is an unordered collection of unique items, ensuring that duplicates are automatically removed. For instance, my underscore set 1, 2, 3, 3 defines a set where the duplicate value 3 is removed, resulting in 1, 2, 3. Sets are useful for operations like union, intersection, and difference, which involve mathematical set theory. They are also highly efficient for checking membership, making them ideal for scenarios where you need to store unique items and perform quick lookups. The frozen set is an immutable version of a set, meaning its elements cannot be added or removed after creation. For example, my underscore frozen set 1, 2, 3 creates a frozen set containing the values 1, 2, and 3. Frozen sets are useful when you need a set-like structure that remains constant and cannot be modified, such as when using sets as dictionary keys. These mapping and set types provide flexibility and efficiency when working with collections of data in Python. Dictionaries allow for easy key-based access, while sets and frozen sets offer unique ways to manage collections of distinct items. By understanding and using these data types effectively, you can write Python programs that are both powerful and optimized for various tasks. Other data types. In addition to the commonly used data types, Python provides specialized types like bytes, bytearray, and nuntip, which serve specific purposes in programming. Understanding these data types allows you to work with binary data and the situations where a value may be intentionally absent. The bytes type is used to represent immutable sequences of binary data. It is often used for handling data in files, network communication, or other scenarios requiring raw binary information. For example, my underscore bytes b hello creates a bytes object containing the binary representation of the string hello. Bytes objects are immutable, meaning their content cannot be modified once created. They are essential when working with protocols or file formats that operate on raw binary data. The byte array type is similar to bytes but is mutable, allowing you to modify its content. For instance, my underscore bytearray 5 creates a mutable array of 5 bytes initialized to 0. You can update specific elements in a byte array, making it useful when you need to manipulate binary data dynamically. This is particularly handy in applications that involve streaming or processing binary content. The nuntap represents the absence of a value in Python. It is a special data type with a single possible value none. For example, x none assigns none to the variable x, indicating that it currently holds no meaningful value. The type function confirms this with the output class nuntap here. Nuntap is often used as a default value for optional parameters or to signify that a function does not return a value. By understanding these specialized data types, you can handle more complex programming scenarios in Python. Whether you're working with binary data or managing the absence of a value, bytes, bytearray, and nuntap provide the tools you need to write robust and efficient programs. Checking data types. In Python, the type function is a simple and powerful tool used to determine the data type of a variable or value. Since Python is dynamically typed, the type of a variable is assigned at runtime based on the value it holds. The type function helps you verify or confirm the data type of a variable, which is especially useful in debugging data validation or when working with dynamically assigned variables. For instance, consider the variable x10. Here, the variable x is assigned the integer value 10. To check its data type, you can use the statement print type x. When executed, this will output class int a, indicating that x is of the integer data type. Similarly, you can use the type function with other data types like strings, floats, lists, or even custom objects, and it will return the corresponding data type. This functionality is valuable in scenarios where the data type may not be explicitly clear, such as when working with user input data from external sources or dynamically generated values. By using type, you can write more robust and error-free code by ensuring that variables are of the expected type before performing operations on them. This aligns with Python's philosophy of simplicity and clarity, helping developers understand and manage their data effectively. Practice examples. This program provides a comprehensive demonstration of Python's diverse data types, showcasing how to declare variables and check their types. It covers numeric types, text types, boolean types, sequence types, and mapping and set types, giving a clear understanding of Python's flexibility in handling various forms of data. The program begins with numeric types, including an integer x10, a floating point number y3.14, and a complex number z23j. These demonstrate Python's capability to handle different numerical formats for calculations and operations. Next, it moves on to the text type, where name Python is a string representing a sequence of characters. Strings are one of the most commonly used data types for storing textual information. The Boolean type is then introduced with is underscore active true, showing how Python can store logical values like true or false. These are often used in decision making and control flow in programs. The program also highlights sequence types, starting with my underscore list 1, 2, 3, which is a mutable list. Then it defines a tuple, my underscore tuple 4, 5, 6, which is an immutable collection. Finally, it includes my underscore range 3, generating a sequence of numbers. For mapping and set types, the program includes a dictionary, my underscore dict name Python version 3.9, which stores key value pairs, and a set, my underscore set 1, 2, 3, which ensures all elements are unique. To verify the types of these variables, the program uses the type function. For example, print type x type name type is underscore active displays the types of the variables x name and is underscore active. This confirms their respective types as class int ds, class int ds, and class boolean. This example not only demonstrates how to declare and use various data types, but also emphasizes the importance of understanding data types when writing efficient and error-free Python programs. By practicing such examples, you can gain confidence in working with Python's rich set of data structures. Key takeaways: Python offers a rich variety of data types that allow you to handle different kinds of data efficiently. These data types form the foundation of Python programming, enabling you to represent and manipulate numbers, text, collections, and more. Whether you're working with simple types like integers and strings or more complex structures like dictionaries and lists, Python provides the tools you need to manage data effectively. The type function is a valuable tool in Python for checking the type of a variable. It helps you confirm the kind of data a variable holds, ensuring compatibility with the operations you intend to perform. This is particularly useful in debugging and writing robust code, especially when dealing with dynamically assigned values or user input. Familiarizing yourself with common data types like int, float, str, list, and dict is essential for becoming proficient in Python. Understanding when and how to use these types not only simplifies your code but also makes it more readable and efficient. By mastering Python's data types, you can write programs that are versatile, maintainable, and capable of solving real world problems. And that's all about data types in Python. We've covered everything from numeric and text types to sequences and mappings, and even explored how to check data types using the type function. Understanding these data types is key to managing and processing data effectively in your Python programs. If you found this video helpful, don't forget to share, and subscribe for more Python tutorials. Thank you for watching, and I'll see you in the next video. Keep learning and happy coding.